Fixation and fixatives. Before going into the topic, first we need to know the word histology. So histology is the microscopic study of tissues and organs, and the observations are made on the dead cells or tissues. So if we want to see a cell under the microscope, just like that we cannot keep the cell under the microscope. So we need to do many processes before keeping the cell under the microscope. So for the microscopical studies, the cells or tissues have to pass through the process such as killing, fixation, embedding, sectioning, staining, dehydration, and so on. And the basic motive is the cells become more clear, transparent, unviable for bacterial growth. So when I say unviable, we are making our specimen unsuitable for bacterial growth, and with well contrasted cellular organelles. Our topic fixation is one of the cytochemical method which brings sudden death of cells, in which the morphological organization and chemical composition of the cell remain unaltered up to greatest extent. Fixation gives lifelike condition, and that's what we want. Aims of fixation. Fixation prevents autolysis, self-destruction by their enzymes, and it prevents putrefaction. It is nothing but the bacterial growth. It makes the cell contents insoluble. It coagulates and hardens tissues to prevent loss of easily diffusible substances. So if we didn't do fixation, the cell components in our specimens will be lost and we can't see anything. And fixation reduces cell shrinkage, increases visibility. Fixatives are nothing but the solutions that we use to fix our specimen. And these fixatives penetrate and fix tissues rapidly, evenly, and prevent short and long-term destruction. So we can preserve our specimen for years. Optical differentiation. It makes the cell suitable for staining, help visual differentiation of various cell components. And fixation preserves tissue volume, maintains shape, and the fixatives should be safe, non-toxic, non-inflammable, and non-allergic for the users. And the fixatives should be economical, stable, and readily disposable and recyclable. So these are the aims of fixation, and if we do fixation, we should take these points into our consideration. Types of fixation. So there are two types of fixation. One is chemical and another one is freezing. Chemical fixation. Cells and tissues are fixed by chemical solutions called fixatives. Fixation by freezing. Fixation is done by a process of rapid cooling followed by dehydration, that is the loss of water, in a vacuum at a very low temperature. And this type of fixation is suitable for the study in X-ray and electron microscope. Further, this fixation by freezing is divided into three. Freezing drying method. Here the rapid cooling is achieved by placing the living tissue in isopentane or propane and cooled up to minus 160 degrees Celsius or minus 190 degrees Celsius by liquid nitrogen or helium. After cooling, the specimen is dehydrated in a vacuum at minus 30 degrees Celsius to 40 degrees Celsius. Fixation by freezing substitution method. Here the tissue is rapidly frozen and frozen tissue is kept frozen at a low temperature, maybe minus 20 to minus 60 degrees Celsius, in a reagent that dissolves ice crystals. The reagent may be ethanol, methanol, or acetone. Next, fixation by freezing etching method. Here, the material is frozen by keeping it in glycerol at a temperature of minus 100 degrees Celsius. Then, it is mounted on a chilled holder and is splintered with a knife to get its cross section. Splintered is nothing but we are breaking the specimen to get its cross section. Now the splintered separation is freeze dried and is covered with platinum and carbon coating in a high vacuum of a freezed ultramicrotone. Ultramicrotone is a device by which we can cut the specimen extremely thin. The dried material is taken out and placed in water so that we can get the replica. Now the replica is washed and mounted and dried for electron microscopic study. The replica gives the outline of various cell structures. So I said there are only two types of fixation, right? One is chemical and another one is freezing. But there are few other fixations too. So first one is physical method of fixation. It is a heat and microwave fixation, but it is not commonly used in histology as it damages the tissues. But it is usually done to bind the specimen to the slide. Next one is immersion fixation. The whole specimen is immersed in liquid fixatives. So in museums you have seen big jars filled with fluid. It is nothing but the formalin, and inside you can see the human embryos or eggs of amphibians or the embryos of tiger, lion, etc. So it is nothing but the immersion fixation. The whole specimen is immersed in the liquid fixative. Next one is coating fixation. Here the fixatives are sprayed and it is used for the easy transportation of slide. Next one is vapor fixation. Here vapor of chemicals are used to fix the specimen. Finally we come to the perfusion fixation. Here the fixative solution is infused in the arterial system and whole animal is fixed. Using this fixation, organs like brain or spinal cord can be fixed. Fixatives. As I said earlier, solutions used for fixation are called fixatives. They differ for each tissue depending on the chemical nature and type of different cells. Example, nucleus and chromosomes are fixed using acid fixatives. So fixatives are of two types, simple and compound. Simple fixatives are nothing but a single chemical solution. But when we take compound fixative, it is formed of two or more chemicals. So these fixatives have some functions, some specific functions. For example, formalin. If we take formalin, it fixes Golgi apparatus, mitochondria and enzymes. When we come to mercury chloride, it hardens and causes cell shrinkage, but it also fixes all type of proteins and carbohydrates. When we come to picric acid, it acts both as a fixative and a stain. So it is important that we should select the fixative first before we are doing a fixation. Mechanism. When a tissue is immersed in fixative, the cells don't die immediately, but they undergo postmortem changes in pH and enzymatic actions. So consider this as a jar, and we have fixative in it. Now we are placing our specimen in it. Now what happens is, this fixative will enter our specimen by diffusion, and the cells on the surface are fixed first and the cells located internally are fixed slowly. Now the rate of fixation depends on the penetrability of the fixative. So if we want to increase the rate of fixation, we need to increase the penetrability of the fixative. So the rate of penetration of fixative is determined by the nature of protein precipitate. So consider this as our specimen, and we have protein molecules in it. So when the fixative is entered, it will form cross linkages between these protein molecules and it will precipitate the proteins. So if the precipitation is very fine, it forms a barrier and further the fixative can't move. And so it is given that the rate of penetration of the fixative is determined by the nature of the protein precipitate. So now I told that the fixative acts on the protein, right? So it acts on the macromolecules like protein and lipids. And also I told that if the fixative forms cross linkages, right? So these cross linkages are formed by two types of fixatives. One is non-coagulant cross-linking fixative and another one is coagulant fixatives. So when we use this coagulant fixative like methanol or ethanol, they remove water from the cell and cause destabilization of H bond and thereby disturbs tertiary structure of protein and maintain it in secondary structure. But the thing is, it causes cell shrinkage and removes soluble substances. And so this is not good for the fixation. So better to use the non-coagulant cross-linking fixatives because it works even better than the coagulant fixatives. So I have given formaldehyde as an example to explain the mechanism. Formaldehyde combines with water to form methylene hydrate and can react with more water molecules and various side chains of protein and nucleic acid. So this is the formaldehyde and it combines with the water to form methylene glycol. Now again this formaldehyde combines with the side chain of protein and forms methylol. This methylol is combined with another side chain of protein to form the methylene bridge. Now various methylene bridge are formed and the precipitate of protein is made. Another example to explain the mechanism is osmium tetroxide. Mainly used as a fixative in electron microscopy, it causes oxidation of unsaturated bonds in tissue, particularly lipid. Converts unsaturated fatty acid into stable glycol osmate. It can also form cross linkages. So this is the unsaturated fatty acid which combines with the osmium tetroxide and forms a glycol osmate. When this osmium tetroxide is combined with two unsaturated fatty acids, it forms cross linkages. So by this cross linkages, the lipids are precipitated. So here are the advantages and disadvantages of the fixation. So when we see the advantage, the cell components and structures can be studied even after the death of the animal. Rare animals can be preserved and it helps in various disciplines like histopathology, anatomy, microbiology, paleontology, microbiology, botany and forensics. So when we come to the disadvantages, artifacts in fixation gives the structures which are not present in the living organisms and affect the accuracy of observation. So in fixation, when we use mercury chloride, it forms a dark brown irregular deposit, but which is not present in the cell, right? And when we do improper fixation, it gives fuzzy staining, that is the improper staining or blurred staining is obtained. Then when we use formalin, which are toxic, so we should handle it with care, and prolonged exposure can also cause health implications. And when we do fixation, the natural color of the specimen is lost. Here are some tips to keep in mind while doing fixation. Tissue should be free from excessive blood and should be thinly cut. Amount of fixative fluid should be 20 times more than the volume of tissue. Tissue with fixative should be in a tightly screw-capped bottle. It can be kept in open place. In preserved specimen, the liquid should be changed after a particular period of time, maybe a year. Factors affecting fixation. pH of the fixative should be neutral or 6 to 8. Temperature should be taken into consideration. Duration. For example, formalin fixes 1 mm per hour. So, if our specimen is 2 mm and if you're keeping it in formalin, we have to keep it for 2 hours, not less or more than the hour. Osmolarity. Mild hypotonic 400 to 450 m osmolarity is recommended. Concentration of fixative should be taken into consideration. Agitation. It increases the rate of penetration of the fixative, so slow, gentle agitation is preferable. Thank you for your patient listening.